Hello, and welcome back to the video lecture series for Introduction to Data Programming using Scala. In this video we continue talking about refactoring, and we're focusing still on smells. So we're going to talk about a few more smells that can occur in your code. Some of the names of these smells can be interesting, humorous, and there are some of those in this next group. One of my favorite ones is a smell called shotgun surgery. Now, obviously, shotgun surgery would be a very bad idea, and therefore it's also a smell. In order to see shotgun surgery, you can't really look at a piece of code. At least it's unlikely that you'll be able to look at a piece of code and say, "Oh, this smells like shotgun surgery." Instead, shotgun surgery is something that you start to kind of feel in your code as you work on it for a while. Okay. The idea is that with shotgun surgery, you have a particular change that you need to make, and when you make that change, instead of just touching one piece of the code, you wind up hitting multiple different pieces of code and making little changes in each of them. Now, this is a smell because if you notice this, that means you're doing this occasionally, and every time that you do it, you have to make sure you hit every place in the code. If you forget something, then you have a bug, okay? And that's bad. Okay? That's why shotgun surgery is a smell, because if you have to edit multiple locations and you forget one of them, and inevitably in the end you will forget one of them, then you have this situation where you need to refactor things. So that's why one of the things that we would want to avoid. In the drawing program in the book, one of the areas that can be a kind of a shotgun surgery is early on when you're adding new drawables, you might have to hit multiple pieces of the code to make them all work. And so we want to change that to reduce it, to make it so that we hit one, maybe two pieces of code when we add functionality. Now, another smell that is often closely related to shotgun surgery is what's called switch statements. Now, if Scala is your first programming language, you might never have heard of a switch statement before, or maybe just in passing. Scala's equivalent is the match statement. Now, this doesn't mean that every time you have a match, it's a smell. Okay, once again, remember the whole thing about smells is that magnitude matters, and in some ways there's also a preference. It's much like style in writing code. So how do you know if your switch statements are smelly? Or in the case of Scala, your match statements are smelly? Well, a lot of times they're smelly if you wind up doing shotgun surgery on them. So if you have multiple match statements that all have the exact same set of patterns in them, so they have the same cases in all of the different situations. Now, they don't necessarily do the same thing. Okay? That would be a different smell. But each match statement has the same cases in it and then different behaviors. Okay? So I'll just go down here and so the idea is that I have a match case A rocket, and then one piece of code in here, copy, oops, Control Z, paste, 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 for cases B and C and D. And this same structure appears in multiple places in my code. Now, what happens in the ... might be different every time. But I wind up with these same match statements. And what I find that I'm doing, and this is when it becomes a smell, if I find that what I'm doing is I'm reasonably frequently adding a new case. Well, now what happens? Because every single one of these matches had the same set of cases, I have to find every one of them and add this new case to it. You can see how that's like shotgun surgery, okay, where this is the change I'm making is I'm adding a new case, and that is shotgunned out through my whole code. What can you do about this? Well, it turns out the way to deal with this is to use some polymorphism instead and make it so that we have some supertype, and each one of these cases is a subtype of it, and each match statement relates to a method. And we'll hopefully come back and illustrate that in another video. So that is how switch statements can be a smell, or in the case of Scala, match statements can be a smell. Now, closely related to this, I mentioned earlier that if you have these match statements and they all have the same cases, or if they were all the same, well, if they're all the same, then that's the smell for duplicate code. And this is something that I know I harp on a lot with my students, and it appears in the book, and I talk about it in the videos. Duplicate code is smelly. You don't want to repeat code. Anytime that you find yourself doing a cut and paste of code, if you cut and paste once, okay, maybe. You cut and paste twice, well, now you should start to think about how you could change your code up so that whatever it is that you're cutting and pasting isn't duplicated. How you could put that inside of, for example, one method or one function and make it so that you can reuse it over and over. Now, of course, the challenge is a lot of times when you duplicate code, you go and you make your other copy, and then you make changes in it. And so, for example, how did we deal with this? Well, when we first did our sorts, we had this problem of duplicate code, in that if I wanted to have a sort for ints, I would write a version of sort that sorted ints, and then I'd write another version for doubles and another version for strings and another version, and they were all nearly identical. There were just such small changes between them. And we saw, once we learned how to do polymorphism, that we could do something like this, and we could use a type parameter here and pass in a comparator so that we could make our sort work with whatever type we wanted. And that reduced our duplicate code. So polymorphism is a powerful tool in removing duplicate code. But sometimes, so is passing functions, because it turns out that sorting in different orders is something that is challenging in many languages, but it's not a problem at all in Scala, because we can pass through functions. So the whole idea of abstracting away things and trying to make it so you have one copy of the code that happens in an abstract way typically reduces your duplicate code. Now, with so many of these smells, it can be smelly. What you do to correct one smell, if you take it too far, can actually create another smell. And in this case, when you first start writing your code, if you say, okay, I want to try to make this as powerful and general as possible, then you've fallen into the trap of creating what's called speculative generality. In the case of our sorts, it is probably true that we want our sorts to be able to use different comparisons. But it's not hard to imagine a situation where you're always doing the same sort and you're sorting on one thing, and it turns out the code can be faster and more efficient, possibly even easier to read, if it is custom coded for a particular thing. And so if you're not doing it a lot, it turns out that if you write a method or a class and you make it remarkably general so that it can handle all types of things, you put in polymorphism, you put in passing functions into it, and you make it so that it's really powerful and general, that can become a smell too. Because it's only a smell if you don't use it. Okay? And that's why it's called speculative generality. Generality in general is a good thing. Okay? But speculative generality is when you put generality in your code and you didn't actually need it. And this is why, so this refactoring is an approach that's used in what are called agile development techniques. And the idea is when you write the code the first time, you just make it work. Okay? We talked about the agile methods when we were talking about unit testing. Okay? The fact that the unit tests were supposed to give us courage so that we could come back and edit our code, and as long as the tests continued to pass, we felt confident in the changes that we had made. Okay? Refactoring is actually closely related to that, because as I said, the idea of refactoring is to change how something gets done, not what gets done. So all of your unit tests should pass before and after the refactoring, and you should be able to clean it up. So in the case of things like speculative generality, the appropriate way to go about developing your code is when you write it the first time, okay, unless you happen to know that you are going to need a certain type of generality, write it in a way that isn't general. Okay? Maybe write your bubble sort the first time so it only sorts ints, and then test it and make sure it works. If all that you ever wind up sorting is ints, you're done. Okay, that's fine. However, if over time your project you find, oh wait, I need to be able to sort doubles and strings and all these other things, well then in that case you modify your sort. You actually do a refactoring. You would take the version that uses ints and you would convert it to something like this and then change the calls to it so that they take a comparison. Okay, and then what that allows you to do is to have the refactoring gives you the flexibility, but it only gives you the flexibility when you find you actually need it. Okay, you don't have to put in all of that generality to start with. So that's going to be it for this video, and I'll come back in the next video and we will talk about our last three smells that we're going to deal with in the videos, and then we'll look at some refactoring and how Eclipse can help us do some refactoring.